So Hanna, we've all seen aphids on our rose
Yes.
bushes and the things, and sometimes they just multiply like mad
Yeah.
without sex, right?
True.
And then sometimes they do sex.
Yes.
How do they know?
How do they know? Until quite recently, I had the wrong idea about aphid life cycles. So when I saw one with wings, I told everybody, hey, this is a sexual one. When I saw one without wings, I said, oh, this is the one that's happy to stay and, just replicate. Turns out that they can be winged or wingless independently of
Really?
whether they are sexual.
I always thought the same thing.
Yeah, exactly. And that is really cool because it creates the question of polymorphism in general, meaning different types coexisting. Males and females are also kind of a polymorphism.
Yes, they are.
Having wings or not having wings is also another dramatic example. And why such diversity can coexist, that one type is not fundamentally better than the other, that's a really fun evolutionary question.
Right. So there's this technical term, frequency-dependent selection. Can
Yes.
you explain what that means?
So that means that if, for whatever reason, you are the rare type, you do better than the common type. And that leads to the cycling that whenever you have become rare, whoa, natural selection favors you, so you become common again. But now the other type is rare, and therefore you can keep coexisting, both of you in the population, because nobody is always the better one.
So let's talk for a minute about why there are approximately equal numbers of males and females in a lot of species.
In a lot of species, yes.
Not all.
Not all, yeah.
But why not just make a bunch of daughters because they're guaranteed? Why not? Why have equal numbers of males and females?
That has to do with the fact that at some level you think it would make sense to have, for example, very many cows and only a few bulls, because one bull can fertilize them all. But if you think about cow, that is the mother of this lucky bull that is then having lots and lots and lots of young, then that original cow mother has a fantastic number of grand offspring. Whereas those who were producing the females, they only have, a relatively modest number of grand offspring. Right. So even though one bull is capable of doing lots, if very few ones are doing that, it's very beneficial to start participating in that genetic game and produce another bull to sort of start eating that pie.
So it's a very interesting thing that even though having a species where most were females, a lot of species, it's pretty much equal numbers. Why, if something's good for the species, why not make more females?
Because natural selection is a funny thing. It doesn't actually think very much about what is good for the species, and that surprises people sometimes. There's a lot of examples where a certain genetic tendency takes over, even though it's not good for population growth. And this is actually a beautiful example of that. It would be great for population growth if a population overproduced females compared to males.
It would just grow faster.
It would grow faster. But what happens is that if then one deviant female decides its genes are dictated to produce a bit more males, it will have a lot more grand offspring, because these males have fantastic mating success in a population that is mostly
if there's just a few of them and lots of females.
Exactly.
So this, I think it was J.B.S. Haldane, the great British biologist in the earliest 20th century, who talked about which bar you might want to go to. And if you're a guy, you're going to want to go to the bar where it's almost all gals. And if you're a gal, you might want to go to the bar where it's almost all guys. And he essentially said, if a mother is trying to decide, not actually decide, but figure out, and she should have members of whatever sex is in short supply, because that's going to get her the most grandchildren.
Exactly.
Does that make sense?
That makes sense.
Was it really J.B.S. Haldane who said that? Do you happen to know? Not sure.
I'm not sure.
I think I remember reading that years ago.
Yeah.
So that's very surprising to many people.
That is, yes. Yeah.
Let's pause here for just a moment and then go on and talk about the delicate sex that dies young.